Well, good morning, everybody. And thank you for joining us on this rainy day. My name is Robert Emmons, the current president of KISCO, at least till the end of this year. For those that have not been to a KISCO event before, we're the official ASCO state affiliate of the Commonwealth of Kentucky and a chapter member of the ACCC. We provide educational content, resources, and advocacy support to help keep ahead of the challenges, and that includes this meeting today on immunotherapy to try to bring us all up to date on this exciting and very rapidly expanding area. This is the first of our 3 events this year. Our next meeting will be our annual cancer conference in the fall, but we'll also have a political events meeting in Lexington next month in June. If you're not an ASCO member and interested in becoming a member, or KISCO member, please talk to one of our staff and they'll direct you to the website to learn how to do that. And on behalf of the board, I'd like to absolutely thank our 25 corporate sponsors to support our mission and improve patient outcomes for the treatment of cancer in Kentucky, including on our premier circuit, Gilead, Merck, and Regeneron, and our platinum members, B1, Bristol Myers Squibb, and Jazz Pharmaceuticals, along with all of our gold corporate members as well. Thank you all for coming today and participating in this important meeting. Another announcement today is that we're changing the logo of KISCO to recognize the changing nature of oncology. And what you can see here is sort of the yin and yang of the 2 aspects that have now become the center points of understanding cancer, its development and its treatment. The KY represent the genetic changes that heretofore had been thought to be the main and only issues in cancer, and the C and the O are the T cell engulfing the cancer cell, representing the immunologic side of things, which is now becoming the second critical issue in terms of our understanding of cancer development as well. So you'll see this on our website and throughout all our promotional brochures to come. Finally, I will mention before we start that we have a QR code for you to scan for credits. I'd like to remind you this session today are 3.5 continuing education credits in addition to the QR code on the screen. An email will be sent after the meeting for you to complete. Okay, so a couple of quick introductory comments about the nature of cancer. Going over 100 years ago, Cooley had suggested that cancer immunotherapy might be possible, and he was injecting people with various microorganisms in his day, which had some interesting tumor responses. There was no understanding of what this really was, but he made a big splash when this was first presented in the early part of last century. So the understanding of cancer was largely a genetic issue for about 50 years. DNA structure was worked out. The Philadelphia chromosome was defined in 1960. The Sanger method for DNA sequencing was developed. The first cancer-causing change of HRAS in bladder cancer was documented. And then the first molecular blocker of a malignant transformation, the Abel kinase inhibitor, was discovered, imatinib. And that took us 50 years. Then things started to speed up as of the change of the millennium. And the first draft of the human genome, BRAF mutations for melanoma, HMAPs, GWAS studies, international genome sequenced, understanding of genetic evolution, and the BRAF inhibitor discovered for melanoma. And then, over the 100 years of evolution, T cells in cancer directed, some trials were done with very poor results. Peptide vaccines were developed, again, very poor responses. Cytokines, we knew boosted T cell response, but we couldn't really make a cancer difference. And views of immunology at that time stressed the importance of self, non-self. And the thought was that cancer is of self, and therefore the immune system really didn't play that great a role in cancer because it would never recognize cancer because it was part of us. But this changed with the realization of the danger model. And along with that, the understanding of immunosurveillance and how important that is for the prevention of cancer developing and proliferating through the body. And the modern understanding of tumor immunoediting has 3 outcomes, either tumor elimination, equilibrium, or immune escape. Then we understood now that the T cell requires co-stimulation, and so from antigen-presenting cells to T cells, co-stimulation is critical for a full T cell response, and the cancer cells themselves inhibit T cell attack through secondary receptors as well. And now there have been so-called checkpoint inhibitors that have made such a big difference, and as everybody is aware, this anti-CTLA-4 and anti-PD-1 data in melanoma, which was published only about 10 years ago, exploded the field. And that really has been the truth for only the last 10 years to really show you the sort of speed up of this. So because cancer patients have tumors, they by definition have escaped immunosurveillance, hence we don't have as much information about how that early step happens, but we do know there are expressed tumor antigens that can cause immune escape and contribute to immune response. And interestingly, Rosenberg showed that tumor antigens are unique. It's not that we can just vaccinate somebody to one tumor antigen and it'll be the same for everybody else. And that's a very important insight as far as the future of how we understand immunotherapy and targets for this. So today you're going to hear a lot about T-cell therapy, CAR-T therapy, TILS therapy, not as much about recombinant TCR therapy, but I just want to show you that this is an exploding field and there's lots of different technologies coming down the pike. You'll also hear about BiTE therapy, bispecific antibodies that bring T cells to their cancer, either on the solid tumor side, on the liquid tumor side.